since now we have to do a lot more calculations, I'm going to use what you've seen before, but let me show you more examples after, so that you have enough examples to work with. Let's see. If you use the same example over and over again, it's easy because you've seen it before, but then you kind of get a little nervous because you haven't seen other examples. So I'm going to show you other examples, don't worry, okay? So we're going to still work with the same thing. This set we've been using. We also prove that this is the basis, right? It's the basis. Let's pick one element in here. Just give me one element in V. Just anything. Give me one.
1, 2, -3.
1, 2, -3. Okay. So 1, 2, -3, and actually we did this calculation. This is 1 times 1, -1, 0, and then plus 3 times 0, 1, -1. So let's just check 3. Yeah. So this is right. Okay. So we have this. Then we say we write 1, 2, -3 as equal to these coefficients, 1, 3, and like that. Okay. And this here is known as the coordinate matrix relative to a basis. Okay, so if you pick a basis and it gives you a representation of this point in the vector space as a matrix. Now this is nice because you see we needed 3 numbers to represent this point, but we know that this is a 2-dimensional space. So any point that belongs in here should be represented by just 2 numbers, not 3. Is that right? Okay. And in fact, if you use this basis, you can just limit yourselves to 2 numbers rather than 3 numbers. Good? All right. So let me give you some time to try this one out. Okay. So try 3, 4, 3 minus 4. And then positive 1. Okay. So your goal is to rewrite this as something with this basis, with this chosen basis. Okay. So, and then if you're done with that, let's use the other basis that we defined, which is 0, 1, -1, and then -1, 0, 1. So try again the same vector, but using this other basis. Okay. So try to find out these 2. And in next week's quiz, the first question will be something like this. It's easier than the other thing that I'm trying to show you. I think I'll have some time to do the other one as well. What did you get for the first spec?
3, -1.
3, -1. What did you get for the second one?
-4, -3.
So let's see how we can get that result. So for A, we're trying to say 3, negative 4, 1 is equal to something times 1, negative 1, 0, plus something times 0, 1, negative 1. Now if you simplify this, you get a comma negative a plus b, negative b, right? And then these two have to be equal. And if you look at the first guy, a has to be 3, right? And if you look at the second guy, negative a plus b has to be negative 4, and negative b has to be 1. But while doing this, you already found out that a has to be 3, and negative b has to be 1, which means b is equal to negative 1. So you get 3 and negative 1, and therefore you put 3 here and negative 1 here. Same thing here, you write down 3, negative 4, 1 equal to a times 0, 1, negative 1. I'm using this vector now, this basis. B times negative 1, 0, 1. And then you multiply a, multiply b. What's that? That's 0, comma a, comma negative a, right? Then if you multiply b, that's negative b, comma 0, comma b. Then if you add them and simplify, you get 0 plus negative b, that's negative b. A plus 0, that's a. Negative a plus b, that's what you get, okay? And that has to equal to this, so you get negative b has to be 3, and a has to be negative 4. So that's why you get negative 4 and negative 3. Okay, so now let's think about another example. So we are going to accept that the following is a basis for R4. Okay, so we have 1, negative 1, 0, 0, 0, 1, negative 1, 0. Then 0, 0, 1, negative 1, and then 1, 1, 1, 1. So we're just going to accept that this is a basis for R4 without proof. Find the coordinate matrix relative to matrix of, let's just pick some random vector, so let's say 2, negative 1, 3, and then negative 2. Relative to b. Okay. So in other words, find. So if we call this as V, find some matrix so find the matrix A and find two numbers A and B. Oh, not A and B, sorry. It should be, it's 4-dimensional, so it should be 4 numbers. That's equal to B. That's what we are looking for. Okay, that requires a bit of a calculation, okay? So that's a more substantial question. So if this one is probably too simple for a quiz, that's actually more realistic for a quiz problem. So try to see if you can solve that. Okay, I think calculation is not that easy, so let's do this together. So what are we trying to do? We're trying to say that 2, -1, 3, -2 is equal to a times 1, -1, 0, 0, plus b times 0, 1, -1, 0, plus c times 0, 0, 1, -1, plus d times 1, 1, 1, 1. Now, it's hard to see, but if you write everything with column vectors, it's somewhat easier. So let me just rewrite the same thing, but with column vectors. So if we have 2, -1, 3, -2 equals to a times 1, -1, 0, 0, plus b times 0, 1, -1, 0, plus c times 0, 0, 1, -1, plus d times 1, 1, 1, 1, then that's a lot easy to see what's going on, because like you can easily see that if you look at the top, it's 1, 0, 0, 1, so it's a plus d on the top. Right? This is going to be a plus d on the top, and then second line it's -a plus b plus d, and then -b plus c plus d, and then the last one is -c plus d. Alright, so now you have a bunch of equations, right? You have that 2 has to equal to a plus d, -1 equals to -a plus b plus d, and then 3 equals to -b plus c plus d, and then -2 equals to -c plus d. Okay, how should we solve this? Can you give me suggestions? Yeah?
Well, I added the first two and then the last two together, and then I added all of them together.
Yeah, you can just add everything together, right? Yeah. See, because 2 plus -1 plus 3 plus -2 is what? That's 2, right?
Mhm.
And because 2 is same as a plus d, I can say a plus d plus -1 plus 3 plus -2 is also 2, right? But then I can replace -1 by this guy and say this plus this plus this plus this should be 2 as well. Then you keep substituting and say, oh, you end up saying, oh, this plus this plus this plus this should also equal to 2. Does that logic make sense? Okay. Since if you're adding the same things together, then the end result should be the same as well. That's what I'm saying. Okay. But if you do that, then a plus -a is 0. B plus -b is also 0. C plus -c is 0. And then what do you get? You get d plus d plus d plus d, so that's going to be 4d. Right? So that gives you d equals to 2 over 4, which is 1 over 2. Okay? Alright, that immediately tells us what a is. What's a? A is 2 minus d. If you use this, right? A is 2 minus d. So that's going to be 2 minus 1/2, which is 3 over 2. Okay. And then you can replace this one here and say b, if you solve this one for b, b is positive a minus d minus 1. A is 3 over 2, minus 1/2 minus 1. Oh, so b is 0. Okay? And then for c, I can move c over here and move 2 there, so you get c equals to d plus 2, and that's going to be equal to 1/2 plus 2, which is 5 over 2. Okay? and therefore we got all the values, A, B, C, D are all obtained, and the answer would be that 2, -1, 3, -2 is equal to A is 3/2, B is 0, C is 5/2, then 1/2. Relative to this basis. Let's try it. All right, so this case, again, let's try writing it down as column matrices. It's easier to read, okay? So 3, 1, -2 is equal to something times 1, 1, 1 plus something times 1, -1, -1 plus something times 1, 1, -1. And now, although you can kind of write this down as what we did previously, I want to show you something else that you did in previous class. So you can rewrite this as right? Do you agree? As you can see, if you do this times this, this times this, this times this, that's exactly the same as this guy, right? So that tells you that 3 should be A plus B plus C, 1 should be A minus B plus C, and then -2 should be A minus B minus C. Is that what you got? Is that exactly what you got? All right, so you can do this. But the reason I'm writing it this way is because if you write it this way, there was another method that you learned how to solve this. What was that?
Reduced row echelon.
Yes, REF, okay? So one thing I ask you to do is on Wednesday's quiz, I want you to bring a calculator that can do RREF, okay? So TI-84 can do that, many calculators can do that. I think even some scientific calculators have REF, but they're limited in size, so I want you to bring a graphic calculator if you want to make your life easier, okay? Yeah. Or else you'll have to calculate this by hand. But let me just give you a review of what REF was. So you write down 1, 1, 1, 1, -1, 1, 1, -1, -1, and then bar, and you put 3, 1, -2, just like that. And then of course in your calculator you don't have this way to put bar in there, so you put matrix and new matrix. How many rows does this have? 3. How many columns?
4.
4. It's a 3 by 4 matrix, right? So you say 3 by 4 matrix, and you make a new matrix, and you enter these numbers, and then you just click REF of that matrix, and boom, you have the answer. That's how you do it. But if you want to do the REF by hand, how do you do this? The REF method is you have some elementary operations, elementary row operations, right? Elementary row operations are that you can multiply whatever non-zero number to a row. You can switch any two rows, and you can take any multiple of one row and add it to the other. And if you think about where those come from, it's really the same thing as trying to solve the system of equations, because if you have a system, you can always change to equations without a problem. You can always multiply some number to any equation that's equivalent, as long as it's a non-zero number. And you can always add one equation to the other, or subtract one equation to the other, or you can take any multiple of one equation to the other. So all of these are just encoded in here. That's what Gauss observed. Like, he got fed up with having to write A, B, C all the time, so he just came up with this basic rules, and he was able to solve equations much faster because he didn't have to write down X, Y, Z all the time, or A, B, C all the time. So that's how this was invented. Very neat. So, but here's what I'm going to do. I'm going to take this one and subtract off of this and this, so that these are both zeros, okay? So 1, 1, 1, 3 doesn't change, but if I subtract this one from here, 1 minus 1 is 0, and then -1 minus 1 is -2, 1 minus 1 is 0, then 3 subtracted from 1 is -2. Oh, okay, so that's already, this one tells you something, right? Okay, and then if you subtract this off, you get 0, -2, and then -2, and then -5. Oh, well, it's not equal, but it's like that. Okay. And the thing that you want to do is to reduce this to a row echelon form, which is like 0 on the entire lower triangular, and then you get non-zero number 1 on the diagonal, and then 0 on above. So you want this portion to be the identity matrix if you can. Okay, that's the idea. So let's subtract this off from here, because that's going to, here I can just divide both sides by -2. So see, in my mind, when I see this, I really have like 0 times A plus -2 times B plus 0 times C equals to negative. That's what happens in my mind. Okay, yeah. See, the textbooks don't tell you that, but if you really understood where the row operations come from, this is what's happening, right? This is really this, right? And you're dividing both sides by -2 to turn this into B equals to 1. Right? So you can already see what's going on here, but let's divide both sides by -2, which is, you get 1, 1, 1, 3, 0, 1, 0, 1, 0, -2, -2, -5. And now, using this, I can kill these two guys, so subtract simply, so you get 1, 0, 1, 2, 0, 1, 0, 1. And then if you multiply by 2 and add to this, you get 0, 0, -2, and then -3. Okay. And I guess one way to write this is like people trying to write the row operation as like here, what you're doing is R2 minus R1 and R3 minus R1. That's what's happening. I'm replacing row 2 by row 2 minus R1. Row 3 is replaced by row 2. Row 3 minus row 1, and here I'm taking half of the second row, or negative half of the second row, to get this next one. And then over here I'm replacing R1 by R1 minus R2, and then R3 is R3 plus 2R2. That gives you that. So you probably have done a lot of these exercises previous linear algebra. That class, in that class, like this is everything, right? They focus on calculation, and you feel like you just have to learn these without seeing the point. So you end up learning the wrong things. You really need to know the concepts, but you end up learning calculations. But anyway, sometimes it's handy. So now you divide everything by -2. This last three by -3, -2. You get 1, 0, 1, 2, 0, 1, 0, 1, and then 0, 0, 1, 3 over 2. And then finally, if you subtract this off, you get 1, 0, 0, 1 half, 0, 1, 0, 1, 0, 0, 1, 3 over 2. And if you do this, this gives your answer for A, B, and C. Right? So the answer would be that you have 1 half, 1, and 3 over 2 under basis B. This is same as 3, 1.